Welcome to Easy Elim Learning Simplified. My name is Ruth, and today we are going to be looking at the topic chemical families, and we're going to finish up on looking at the properties of halogens. We looked at the properties of halogens in the previous lesson. So for this lesson, you look at the remaining properties of halogens and their uses, and then we are going to tackle a few questions in regards to what we are going to discuss. So halogens also usually react with water. They dissolve in water to form two types of acids. For example, if we look at the reaction of chlorine with water, chlorine dissolves in water to form chlorine water. Chlorine water is usually a mixture of chloric 1 acid and hydrochloric acid. Chloric 1 acid is also referred to as hypochlorous acid. So you see that in some books. And then this is the equation. So you can see the chlorine gas reacting with water to form, this is the chloric 1 acid, and this is the HCl. So when you look at the reaction of chlorine with water now in presence of sunlight, we'll see the following properties. So first of all, chlorine water is made by dissolving chlorine gas in water. Then a long tube with chlorine water is inverted over a beaker containing water. Then it is exposed to sunlight for some time. So this is a setup that was used for this reaction. So you can see the chlorine water and the sunlight, it is being exposed for some time. So what are some of the observations that are going to be noted in this reaction? So one of the observation is that after some time, there was a gas that was collected, and this gas was colorless, and this gas was tested by using a glowing splint. The moment you see a glowing splint, you know you are testing for oxygen gas. So when it was tested, the splint rekindled, showing that the gas that was collected was oxygen gas. So this is what happened after the experiment was done. So you can see initially this boiling tube or gas jar had full of chlorine water, but you can see now we have some space. So in this space, oxygen gas has been collected. So when we look at the chlorine water, we said it has two components, that is hydrochloric acid and hypochlorous acid. So what happens, the hypochlorous acid in the chlorine water is usually unstable, and that is the reason why it dissociates when you expose it into sunlight, and it dissociates to form hydrochloric acid and oxygen gas. So this reaction is very slow. That is the reason why we left the experiment for some time, so that we can observe the gas that was produced. So oxygen gas is going to be produced. So the same experiment can be repeated now with a litmus paper. So instead of us collecting the oxygen gas, what if we lowered wet litmus paper, both red and blue, in a gas jar containing chlorine gas, or chlorine water being dissolved in or you put litmus paper, red and blue, in chlorine water. What are you going to see? So if a strip of blue on red litmus paper are dropped in chlorine water, so the blue litmus paper will turn red, because we said whatever solutions that are being formed are acidic in nature, the hypochlorous acid and hydrochloric acid, and then the red litmus paper will remain red. So red litmus paper will remain red, but after some time, both litmus papers were decolorized. So you can see this is a property of the chlorine water. So why is it being decolorized? So we said that chlorine water contains a mixture of chloric 1 acid and hydrochloric acid, and we talked about this equation previously. So what happens is the two acids are the ones that causes the blue litmus paper to turn red, while the red litmus paper remains red. Then we said that they are decolorized because of the action of the chloric 1 acid. What happens with chloric 1 acid? Just like we said that chloric 1 acid is unstable, so it decomposes to give hydrochloric acid and an oxygen atom, as you can see. So that oxygen atom is the one that combines with the dye in the litmus paper to make it to be colorless. So as you can see from the equation. So we have the dye, which is either red or blue litmus paper. So the blue litmus paper, remember, it will turn red, so we are working with the red dye. So the dye will react with hypochlorous acid, which dissociates to form hydrochloric acid and oxygen. And then this oxygen dissolves or reacts with the dye, causing the dye to decolorize. So that is what happens in the action of bleaching of um, of the red litmus paper in this reaction. So if you looked at other solutions of bromine and fluorine, they would react the same way. They also dissolve in water to form acidic solution. So next we look at some uses of halogens. So some of the uses of halogens are, remember we said you have to be very specific with uses. Do not generalize uses of halogens and say like halogens are used in this and this. You have to be very specific on the specific type of halogen. So for example, fluorine is used in the manufacture of polytetrafluoroethane, which is a fiber and it's a synthetic fiber. You're going to learn a bit more later in Form 3 about these polymers or fibers. And then other compounds of fluorine are usually added to water. Some in toothpaste, you've had the fluoride in toothpaste. It usually helps to reduce the tooth decay. Then also fluorine is used in the manufacture of hydrogen fluoride. Hydrogen fluoride is used to engrave like words or pictures on glass. And then chlorine is used to make bleaches that is used in paper and textile industries. And then also chlorine is used, it's added in water to kill microorganisms in water treatment works. You've heard of the how different waters are treated, even the swimming pool or the drinking water. Chlorine is usually used to kill those microorganisms. Chlorine is also used in the manufacture of PVC. PVC is a plastic. We're also going to mention this later in Form 3. Chlorine is used in large scale in the manufacture of hydrochloric acid, and bromine is used in the manufacture of silver bromide, which is used to make photographic papers, especially the ones that are a bit sensitive to light. Then iodine is used as a disinfectant. So we know that from like when you go to the hospitals, it's usually see a solution of iodine that is added or poured in woods, and this iodine is usually dissolved in alcohol. So that brings us to the end of the uses. So next, you're going to look at a few questions in relation to what we have discussed. So the table below shows some properties of chlorine, bromine, and iodine. Complete the table below by giving the missing information. So you have this table with some information. So we have chlorine, bromine, and iodine elements with their formulas and their colors and states at room temperature. So chlorine, we said it's a green, yellow gas, and then iodine we said is a silvery gray solid. Remember, when you heat it, it turns into a purple vapor. And then when you look at solubility in water, we said their solubility decreases down the group because of the size of the molecule, which increases, or the strength of the van der Waals forces. So chlorine is soluble, bromine is also soluble in water. But when you compare their solubility, chlorine will be more soluble. For the next question, chlorine and iodine are elements in the same group in the periodic table. Chlorine gas is yellow while iodine is black. So also other books talk about black or gray. What observations would be made if chlorine gas is bubbled through aqueous sodium iodide? Explain using ionic equations. So we know that this is a displacement reaction. If you were to write the equation, it would be chlorine gas plus sodium iodide, which is also in aqueous solution. Chlorine displaces the iodine in sodium to form sodium chloride, aqueous as well, and iodine is given off, is deposited as a solid at the bottom. So you're going to see some gray specks on the bottom of the beaker. This tells us that iodine is the one that is deposited. So this equation is not balanced, so we balance by putting 2 here and 2 here. So if we look at the ionic equation, it will be chlorine gas plus 2 iodine ions, aqueous, to form 2 chloride ions, aqueous, plus iodine can be solid. So for how we came to this ionic equation, we said when we're writing ionic equation, we usually cancel out spectator ions. Spectator ions are the ions that remain in the same state both in the reactant and the product side. So if you were to write the whole ionic equation, it would be like this. And then the product will be like this. Plus iodine solid. So you see chlorine this side is gaseous state, chloride ions is aqueous, so we do not touch that. Sodium is in aqueous state, reactant and aqueous state product, so we cancel this. Iodine is aqueous state in reactant and solid in product, so it will remain with that. So that is what forms this ionic equation that we have formed. So next question is explain why the reactivity of a group 7 element decreases down the group. So we said down the group, there is an increase in the atomic sizes and this causes an increase in the size of the molecule. So when we talk about reactivity, we are talking about gaining electrons. So we said the one that has the smallest atomic radius is the one that has the highest tendency of gaining because it attracts the nucleus attracts electron easily in comparison to a large molecule. So down the group, there is an increase in the atomic sizes, which causes an increase in the size of the molecule. So the outermost valence electrons are held weakly down the group. Are held weakly, let's introduce by the nucleus down the group. So the ease, or you can talk about the electron affinity, the ease of gaining electron decreases down the group. So you can further talk about the electron affinity also decreases down the group is still the same. So electron affinity is that tendency of gaining electrons and there's some energy that is given off in the process. So that brings us to the end of halogens. So we are done with halogens. Our next chemical family will be noble gases, and that will conclude this topic. So see you in the next lesson as we tackle the noble gases.